call me a biostratigrapher. Algorithms. I'm not actually a biostratigrapher. Biostratigraphy, as I'll tell you later on, is quite a distinct discipline. I tend to concentrate instead on what is called ecostratigraphy. How communities change through time. But over the years, I've worked on the Grasso, Manzanilla, Grasso, Manzanilla, what was the Tamina, which I've now suppressed, and the Sapero formations, trying to sort out the relationships between them. And I've discovered that, for my purposes at least, there is something sadly wrong with our lithostratigraphy. I think it's simply, I don't want to cast any aspersions on Kugler, but the way Kugler operated is not the way we would operate nowadays. In that he used biostratigraphy to erect formations, which is no longer acceptable according to the standard. So, a little bit of revision stuff. What is lithostratigraphy? Well, lithostratigraphy is the recognition of rock units according to their lithological characteristics. In other words, if a geologist goes up to a field geologist in an area for the first time, goes up to an outcrop, they should be able to say what the lithology is. They mark it on their map. Let's imagine it's clay. They mark it on their map, give it a little colour, absolutely green. And if they've got their wits about them and they've got some muscles, they pick up a specimen, put it in their knapsack and carry it to the next outcrop. At the next outcrop, they would look and see, is the lithology the same or is it different? If it's the same, they would mark it on their map and then put it in the same colour. And they would infer that the same rock type extended between those two outcrops. At the end of the day, they should have a map which has got locations on it, and at each location there should be the lithology mark. And they should be able to tell which ones have the same lithology and which are different. They might find, for example, that there's a region of clay deposits adjacent to a region of sand deposits. Those are distinct mappable units. Those are what we call formations. The formations can be grouped into groups. We feel there's some sort of consistency across them. And we can even have supergroups. I don't believe that I've ever come across anybody suggesting we use groups and supergroups in Trinidad, which I think is a lack. But let's leave that aside for one moment. Got a photograph there. I think you can see extending across the middle of the photograph. There is a distinct boundary from one rock type to another. In other words, we're looking at least two formations in that given site. I have no idea where that is, by the way, but it's still alive on the internet. So, what is biostratigraphy? Biostratigraphy is where we use the fossils to show the age, the relative age of a rock unit. And fossils are typically fairly long-ranging stratigraphically, so the same fossil can occur in more than one formation. If you look at the diagram on the right-hand side there, you can see formations have been marked out graphically, and you can see also a range of the fossils, and they're not restricted to one particular horizon. Biostratigraphy. In Trinidad, we use especially planktonic foraminifera for doing our biostratigraphy. We've got a very, very good system for local use. I do believe that once we try to infer ages, correlations over long distances, then things become awkward. For example, the Pleistocene is here defined by one particular forearm called Lower-Italian Cancellinoides. That evolved around New Zealand about 2.82 million years ago. It arrived here about 1.8, and for some reason it arrived slightly earlier in the Mediterranean. There's been some strange migration there. In other words, we can't use the first appearance of Cancellinoides to show the base of the Pleistocene everywhere. But at least locally, we can say that we will use that as a data point. Whether it's based Pleistocene and biowings not is immaterial. You can use it for local biostratigraphic correlation. So, I'm just going to throw this out there because I believe that I'm delighted that today is happening. I'm delighted to see so many new faces. For me, this is just an indication of something that is wrong with the way industry and academia work in Trinidad. I get myself at the top there. That's all because I needed to be at the point of a triangle. I could have been at the bottom of the triangle, could have been the other way up there, and could be going, oh, whatever. But I find out stuff. I love it. I find out stuff. I just need it though. And then I put it in there, because I sit it down there into the big wide world. And hopefully those who are in the industry will then take what I found and apply it to their own work. That industrial work is then handed on to the geophysicists and the geologists in the oil companies. And I find that there is an enormous disconnect at all levels. Those who are working in industry really don't have a clue what I'm doing, which may be my fault. Maybe I don't go out and advertise myself here. And then those who are in industry as geologists haven't got a clue what paleontologists do. You notice? John, obviously you notice, you're easy on me. But I take that as a knowledge. They do. Ask. But I also find that there are very few requests come back. Very, very rarely has anybody in the industry said to me, we have a problem, can you look at this? I think the one exception in the room is sitting in front there. I get occasional emails from you saying, what about this? And that's about it. So I think that's something that we've got to overcome. The North American Stratigraphic Code, which is pretty much the one we work with, unless we're going to work with one of our own, says that formation has got to have some kind of lithic homogeneity. In other words, it's got to hang together as a unit. And it also says, very distinctly, Article 24, that you cannot use fossils to distinguish formations. You can use them to tell you the age of the formation. You cannot say that the extinction of this fossil marks the top or bottom of the formation. What you found there is a biostratigraphic unit, a zone, not a lithostratigraphic one. Another difficulty that we have is that formations are diachronous. I draw this diagram in my lectures to the point where I'm absolutely sick of it. And I'm sure anybody who's been through my classes will recognize this and remember that they've seen it at least half a dozen times. It's a prograding delta, let's imagine. What we have is a seafloor surface, which is a timeline. Right now, there's a timeline, that's seafloor surface. But if we look at the distribution of rocks within it, we have some delta top deposits, which would likely be sandstones. So there'd be clays in there, there'd be coals, shoestring sandstones. We have pro-delta deposits, and then we have the ordinary stuff in the basin. So the boundary between that rock and this one cuts across the timelines. The boundaries between formations are diachronous horizons. That diachronicity may be only a matter of a few thousand years, in which case it really doesn't matter. But if we're looking over a large area, then we can find huge diachronicity from one place to another. There are some rocks that at one end of the Grand Canyon are Ordovician age. By the time you get to the other end, that same boundary is in the lower, it's in the early Devonian. So what's the situation at the moment? Well, we've got lots of fossils, and we define them, crudely define them using lots of formations, define them using fossils, especially forams, not using lithologies, which makes things very, very confusing. It's almost as though Kugler said, look, we got, let's say, 10,000 feet of clay. We got to subdivide it somehow. We'll use the fossils to divide that into formation. I'm sorry, that doesn't work. They should at best be recognized as zones. But if we then recognize that we've got one clay, then we've got something we can work with in terms of how the environment, living environment. So, the Cipero formation is divided into members. The one that springs to mind is the Prince's Town But at the same time, we've got to look at what is the value of the formations that we recognise at the moment. And lots and lots of vague language used in recognising these formations. The Brasso formation, inky blue. I mean, okay, what am I supposed to do? Carry what with me? But who's English? Quince or some other brand, fish or whatever. It means nothing. There are now, thankfully, such things as municipal colour sheets which you can get that can state the colour as well as a code and all agree on it. But your impression of inky blue might not be the same as my impression, which makes us a lot of problems. Okay, I've said lots of problems with the language, so the one thing I really, really hate, ladies and gentlemen, is somebody reads a PowerPoint to me. And yet, most of my examples are in language, so I'm sorry, you're going to have to do some reading. I'll shut up for a minute, I'll just press the space bar, and you do the reading. Hopefully the message will come across. Okay, we're using fossils there to define the topic of formation. Same page within the same book. One formation passes upwards, we have to break into another formation. There's no lithological change there. Right, getting even more specific now. Sorry, getting even more specific now. Very similar to, I'd like to know, well, in that case, what's the difference? I've read that page, I've read that book. It doesn't say it, it's saying very similar to. And then, to put a nail in the coffin of the work, why did we distinguish them at all? Because we used the forems, we did not use the mythology. All on one page in Kugler's treatise on paleontology. I put the almost in bold there just in case the message wasn't leaping out at you. By the way, gravelina neridiensis is about half the size of a pinhead. So any geologist who's out working in the field who picks up a piece of that rock does not know whether it contains that particular bone. You should be able, at the end of the day, a geologist who's mapped the area should be able to see the distribution of pathologies. It should not be dependent on coming back to the lab and finding the fossils. Okay, I mentioned that one earlier, the subdivision of the Scipera formation into members using fossil lyosomes, foraminiferal lyosomes. I believe that Bolly put together the notes on which Kugler 2001 actually knew this was wrong. They also published a book called Benefit for a Different Southeast Caribbean, which has a nice little stratigraphic table for the Middle Eocene through the Miocene Trinidad. And it does not distinguish a tabular formation. So I think they knew this was wrong. I think we've known it's wrong for a long time. What I have found is I've actually written and suppressed the tabular formation. I know the word tamina was used before Brasso, but Brasso as a word has been used a lot more than tamina. So I said, get rid of the tamina, it's actually the same as the Brasso. Think about something else. point to so the lower Concord calcareous silt member is the lowest member, supposedly, of the Tamina Formation. You cannot distinguish it. If you look up to it in the field, if you go to the quarry Gasparillo and take a look at that, you cannot distinguish it in the field from brownstone. And there's no marked unit separating the two. So why? Yeah, some people say, okay, there's an unconformity at the top of the brasso. I don't have a problem with that. Because the top of the brasso is the top of N12 of the Talia Robusta zone. The top of the Tamina, when I looked, I've got 10 papers on the Tamina. Every single unit is at N9, N10A. So that's actually biased. Nonsense, every time. People talking donations. Claire wants to introduce me to the word. The Tamina Formation is a brief limestone. Well, no, I'm sorry, we've just seen that the Tamina Formation is supposed to have two silts. So where does that come from? And there I've given the reference where for those of you, it is available online, it's free. That's where I suppress the Tamina Formation. As I say, it took about 10 papers to get all the evidence together. It's a fairly intensive work. Right, because the Tamina Formation supposedly consisted of two silt members separated by a limestone. Unfortunately, the limestone does not extend the whole way across Trinidad. It's a series of distant bioherms. So what happens between those bioherms? Do we have an upper and lower? And the answer is no, we don't. No. We can subdivide it, certainly. We can subdivide it into biozones, but we cannot say we have an upper and lower length of formation, which differs lithologically. It's the same lithology all the way through, which should be telling us something about the continuance of polyenvironments. But we lose that as soon as we try using biostratigraphy. Don't get me wrong, I'm not saying get rid of biostratigraphy. I think it's wonderful. By the way, I get paid for it. What I'm saying is we're doing it wrongly. So this is one from me. There's a bit of a story behind this one. Forest Park landfill. I was out doing some field work with some second year students, and Clem said to me there's some brasso over there. And I was working on brasso, and I thought, oh good, I'll go and sample that. Which I did. Then I got back to Uli, and I looked at the top map, and lo and behold, it was the San Jose calcareous silt, the lowest member of the Manzanilla. But the truth was, I could not tell the logic, except for the presence of, and I call them occasional light-grey nodules. I think I found two. It was the only thing that told me in the field, this is not brasso. In fact, my own feeling is that the San Jose calcareous silt should be part of the brasso. The Manzanilla should not commence until we get the Manzanilla sandstones. Okay, let's see, what can I say here? This is me getting into some ecostratigraphic statistics where I've looked at the foraminifera community throughout part of the Manzanilla formation, Manzanilla Bay and Point Noir. I looked at which samples contain the same basic fauna. Now this is ecostratigraphy, not biology. But what I found was that the samples do not group in a nice coherent manner. So Sorry, moving on, nearly finished. Same thing, just plot it out on the graph. You can see that Hans-Alving carstacy occurs repeatedly and is separated by the biofractions. In other words, we can't use that because it's an indication of Shazamming. Where is he? Shazam. Where one formation or one biostratigraphic unit or one whatever interferes with another. I've got there a cross-section of the Cretaceous of the Western Interior of North America. As an example, you can see Shazam.
We don't know that character.
So, should we reduce the number of formations? Well, my own answer will be yes. We've got a lot that we can put together. We can still subdivide the biostratigraphically, but I think lithologically we've got to put them together. So as a conclusion, we've got to separate biostratigraphy from lithostratigraphy, and I think, for my own peace of mind, I'd like to see ecostratigraphy separated from biostratigraphy. We have good local biostratigraphic control using 24 amps. What we need to do is to separate that succession into workable units, lithostratigraphic formations that make sense. I think the geological history will be a lot easier to interpret. Thank you.
Thank you.